back. It slows down. That slower wave can't penetrate the atmosphere. It interacts with these greenhouse gases now instead of going through them. So that energy is kept in the earth, warming the atmosphere and warming our planet. That's the greenhouse effect. Radiation from the sun, when it's reflected from the earth, is trapped in our atmosphere by greenhouse gases. It's like a blanket around the earth. That's the greenhouse effect. Alright, so some sunlight is reflected to space. The rest of that light converts to a shorter wavelength that we can't, or longer, sorry, that we can no longer see. Right, the visible spectrum is a small frequency of wavelengths, and then turns into heat. That heat is trapped by the blanket of greenhouse gases. I think I have here, yeah, water vapor, CO2, methane, and thanks, Alex, NOx. Is this a good or bad process? Hands up for this is a good process. Hands up for this is a bad process. Okay, I'll give you some info. Maybe you'll change your mind. Life doesn't exist without the greenhouse effect. This is a crucial physical process for life to exist on our planet. It makes the earth habitable. It means it's warm enough for us to be here. It means when the sun goes away, it's not freezing cold every night. The greenhouse effect is a natural effect that makes the earth habitable. So, why do we care about it for climate change then?
That happens too much, if it warms up too much, there's like this medium effect, right? Like you absolutely have to have it, but too much of a good thing is bad.
Exactly. It's like we have a sheet in the Florida summer on our bed, right? We have a sheet on. I hate sheets, but some people enjoy sleeping with sheets, right? Let's say you have one sheet on your bed. Anthropogenic climate change, human-caused climate change, amps up this natural process. Greenhouse effect is fine, it's a natural process. But when we influence the concentration of greenhouse gases in the atmosphere, it's like we're throwing extra blankets on, right? That's when we run into issues, when we start changing the thermostat. So that's like in Florida summer, instead of a sheet, you had 3 comforters on top of that sheet. Now, I don't know if that's comfortable for y'all. I'm not from down here, but that would kill me. I would be so uncomfortably warm in the summer with 3 comforters and a sheet on, as opposed to 1 sheet, right? That's why we care, and we'll get into that. So what is climate change then? First, what's climate, right? We talked about climate. It's the long-term average, right? Not weather, which is short-term, but the long-term over decades average of temperature and precipitation. It's influenced by global patterns of heat moving around and water, evaporation. We talked last week about how climate leads to specific vegetation communities, biomes, right? So what then is climate change? Change in temperature and precipitation regimes, right? Outside of the usual limits. So I think this is the, yes. So here I actually wanted you all to come up with questions or ideas you've heard climate change. Right, this is something that I work on in relation to my research in wetlands, especially carbon cycling. But climate change, what have you heard? What questions do you have that you would like answered or addressed? If we have time, we'll take time to do that during this lecture in the next 45 minutes. We'll go over some of the science behind it, but if you have open questions that you'd like us to discuss, we might be able to do that. What have you heard? Whether you think that's accurate or not about climate change? Yeah. The ones we do have will be stronger, right? Which means more destruction, more loss of property and life. If you like corals, Florida has the third largest coral reef in the world, right? The Great Florida Reef. Corals don't really like climate change for a number of reasons. Heat waves, and when you have a lot of CO2, it dissolves in the water and causes ocean acidification, right? Acidified water and heat waves, marine heat waves, lead to coral bleaching, where the coral dies. It loses its symbiont, which is a dinoflagellate, which you all know very well and remember, right? It loses a dinoflagellate, and then if it's too hot for too long, they die. Right? There's some estimates that most of the world's coral reefs will not exist anymore by the end of the century because of climate change. Maybe most important for us, sea level rise. Is Florida flat or mountainous? Yeah. Do we have a lot or a little bit of coastline? Kind of a lot, like a lot, right? We're low and we have a lot of coastline. The ocean is not far away no matter where you are in the state. Sea level rise is a huge problem for Florida. So, since 2016, in just 30 years, we saw about this much sea level rise. That doesn't seem like much. Right? But if you have a storm that's adding a few feet, and the water is this close to your house, this is a lot, right? If you add this on top of sea level rise, on top of high tides, on top of storm surge, and we built cities to be right on the water, right? Or that nice beach house that I will never afford, and maybe no one else will, is right on the water, right? A little bit goes a long way. So it's predicted just by 2030, just 10 years from now, we get another 6 inches. By the end of the century, we could have a few feet, right? So add another foot or two to sea level, and that just keeps going into the future for the next several hundred years. Not good when more than half of folks live really close to the ocean. Think of our major cities that are on the ocean. A lot of them are ports. DC, right on the coast. Baltimore, Boston, New York, right? Jacksonville, Miami, Houston, New Orleans, San Francisco, all of them, right? LA, Seattle, Portland, they're all on the ocean. That's just the United States, right? Globally, many important economic engines are right on the ocean. So sea level rise is a big problem. Here's what that looks like for us. So the red here is less than a meter of sea level rise. So this is like what we'll see in the next few decades, or what we could see by the end of the century. Notice the Big Bend, lots of marsh there. High exposure for sea level rise. Lots of the marsh around here, the mouth of the St. John's, the ditch, right, separating the beaches and where we are. Lots of areas along the St. John's that already flood with storms. All of South Florida, right, Daytona area, Cape Canaveral, where a hurricane hit last year, right? Look how low that is, how exposed it is to sea level rise. Right? And as we move forward, right, driver. That's called eustatic sea level rise. Right? Water expands when it heats up. Right? You have those molecules, when they get warmer, they move a little faster, they take up more space. I told you most of the heat from fossil fuel combustion that's now in the Earth's system is stored in the oceans. Right? Most of the area is ocean. It's a huge amount of material. Most of the heat is in the ocean. That ocean then expands as it gets warmer. But another big contributor, and what will be a more important contributor over the next century or two, are melting ice sheets and glaciers. So glaciers you can see right, in Montana and mountain areas all over the world. We're losing them really rapidly. They're melting. That water is stored on land right now. It runs out to the ocean, adds volume. What doesn't contribute to sea level rise? Melting, floating ice. Right, if you have an ice cube in a glass and it melts, it doesn't increase the water level. It's already displaced in that water. So big icebergs, the floating sea ice of the Arctic, that melting does not contribute to the volume of the sea. What does are two ice sheets. What are the major ice sheets on Earth?
North Pole and South Pole.
Arctic and Antarctic.
The Antarctic, that's land under there, right? That ice is on land. There's mountains and stuff in Antarctica. It's a continent. It's just buried under ice. So when that ice sheet melts, as it is now, that contributes to sea level rise. And we think we're probably pretty close to losing the western shelf of Antarctica. And I think it's 5 to 10 meters of sea level rise locked in at that point. Which, like, that's bigger than this room. Yeah. But over the course of the millennium. So that's your, you know, kids that drown, not you. But yes. What's the other ice sheet? Antarctica, not the Arctic, that's sea ice. Greenland. Yeah, Greenland and Antarctica are the big ice sheets. So one more contributor to sea level rise. So far we're just talking about the water, right? Water warms up, and when ice from land melts, it adds volume to the ocean. But in coastal cities, sometimes there's also subsidence. What do I mean by that? So if you have the coast here and water, the water's moving up. Okay, that's just sea level rise. But in a lot of places along the coast, because of tectonic movement or because of the land squishing together because it's all sand or lots of other reasons, extraction of groundwater or fossil fuels, the land at the same time is moving down. That's subsidence. So if you have the land moving down, at the same time that the sea's moving up, bad, right? That's called relative sea level rise. That incorporates the ground moving and the water moving up. So in a lot of places that's a problem. In Louisiana, for example, their sea level rise rate from just the water is about 3 or 3.5 millimeters per year. Right? That sounds small, but it adds up over time. But because their land is sinking, at the same time, their actual rate, their relative sea level rise, is 1 centimeter per year. Right? So 3 times higher than just the water movement. So relative sea level rise includes coastal subsidence. So lots of processes driving sea level rise, and that can all be traced back to, right, the warming, the melting, global climate change. Especially the warming portion of that. So I have a few graphs, and then we'll see if we address some of these questions. Has anyone heard of IPCC? Intergovernmental Panel on Climate Change. It's a global organization that releases climate reports every few years. The newest synthesis report came out just a month ago. So this is brand new stuff, a month old, from the Intergovernmental Panel that studies this. It's hundreds of scientists coming together. This one is intense. So, let's start on the left side. Global temperature change, 1900 to 1940, not much different from the long-term average. 40 to 80, a little bit warmer, up to half a degree Celsius. 80 to now, pretty warm, starting to ramp up, around 1 degree C. Here's where we are-ish. And here are our options, right? The future isn't written. We get to choose how miserable the future is. It can be kind of miserable or super hellish. All right? So we're on this track right now, intermediate to high. And you can see that as time goes on, things get really bad, harder and harder to live. 3 degrees C, that's like famine, drought, huge sea level rise, crazy hurricanes, lots of fires, there's not a lot of food, it's bad, right? It's a bad time. Here's where that translates into human lifespans, right? Here are the people who contributed the most to climate change. They get to live in a world and die when it's not that bad, really, right? Here's the next generation. This is more like my generation. We grew up and it wasn't so bad, and then now there are some choices that we largely don't have control over. But when we die, it could either be kind of bad or pretty shitty. But this is like my kids. They're born in a world that's a little bit warmer already. But depending on what we do now, they could die in a world that's kind of warm still, or really horrible, right? And they're not making those choices, right? So the choices that we're making today, which path we're on, have really big implications for the next few generations and how livable the world is, right? And who are the decision makers? These guys down here. Do you think they care what this is? Maybe not. Maybe they should, right? I think I'm going to skip one. This shows impacts to food production. So corn or maize, huge global crop. As we increase the amount of total warming, right? As we choose how much fossil fuels to combust, how much warming to contribute, purple is bad, less yield, right? Notice there's a lot of purple all over the world. Crop yields go down the warmer it gets, right? So if we can limit warming, things are better than if we don't limit warming, right? That's very clear from the science. Same with fisheries. The tropics, which are very productive right now, lose a lot of their fisheries yield. Some of this, which is now under ice, actually becomes more productive. But overall, the net trade-off is in the negative. So the more warming, the more climate change we decide, the worse off we'll be. There's a human health risk, right? Heat humidity risk to human health, right? Historically, in the tropics especially, it got hot a lot, and there was risk to human health. As we increase warming, the number of days increases. If we let it get to 4 or 5, that's almost every day, right? In a big chunk of the world, right? Same with species losses. Okay, here's the kicker, right? So we know it's going to be worse the hotter it gets. We know that fossil fuel combustion directly leads to climate change. We know what we need to do to reduce fossil fuel use. So we're on track to do that, right? No, we're not. Here's what we're we need to do to limit warming to 1.5. Here's what we need to do to limit warming to 2 degrees C. Those aren't overlapping. There's a gap. Right? Our policies, even the ones we've committed to so far, don't get us anywhere close to limiting things to 2C. We're headed more like for 3, 3.5, and that we know that that's going to be a really unpleasant place to live. So we need immediate, rapid decarbonization to avoid really strong impacts. Our climate scientists have been saying that for a very long time. We know this. The good news, and I just want you to focus on a few things here. The good news is we have everything we need to make those changes. We have the technology already today. We have all the solutions. We know what they are. We know how much of them we need, and we know where we need them. And we have a path that we can follow to limit ourselves to 2 degrees C, save a whole bunch of lives and animals, make the world more habitable and less shitty in the future for the next several generations. We have all that we need. There's not a miracle technology that we need to come up with to save us. We have it today. We've had it for a while. Things like solar and wind, for example. Lots of other things on this list. Efficient buildings help, electric vehicles, et cetera, et cetera, et cetera, right? Reducing the conversion of natural ecosystems, stop cutting down forests, right? We know what we need to do, which is good news, right? That's really good news. We're not choosing to do it, which is not so good news. But we can, we could, which is great. So it's not hopeless like we're doomed. We just need the political will to choose. And if we do that, it gives us a lot of good things. So most of these solutions, we call them climate solutions. Some of them are nature-based solutions. You'll hear that sometimes. They give lots of other benefits, right? Often they decrease inequality, which can be problematic for a number of reasons outside of the scope of this class. Right? They provide us cheaper energy. Lots of co-benefits, as we call them. So I'm going to not play this right now to make sure we have time for these questions behind me, and then we might end with a video from Crash Course. They actually, within the last semester, launched a climate and energy playlist of new videos exploring climate change and energy and all those things, which is really a great resource if you want to learn more. But how do we do on our question? Does climate change influence natural disasters? Yes. It increases fires, which we didn't talk about because things are drier, easier to burn. It increases floods because in a warmer climate, the atmosphere can hold more water and dump it out at a faster rate. It influences the strength of hurricanes by warming up the water. Right? Lots of natural disasters are made much worse with climate change. We are absolutely on track for doom, yes, but we know the solutions and we have them. We can deploy them right now. That's good. That's good news, right? Agriculture, absolutely a main contributor because it's converting forests that take up lots of carbon or wetlands that take up even more and converting it to land uses that emit lots of CO2. So agriculture, absolutely a main contributor. Transportation, also a big contributor. Do we really have 10 years? No. We have 10 years to avoid really strong impacts, yes. But if we miss that by a year, you know what we're going to hear from the people in power? Oh, we missed the window, don't worry about it. No, there's always time to act. Always. That can be doom and gloom. We don't want that. Has climate always changed? Yes. Not in this way. We're positive that we are contributing to the fossil fuels, right? We've been burning them since the Industrial Revolution. Is it really humans? Yes. Absolutely yes. 99% of climate scientists agree that climate change is human caused. Right? The only Yes, this is an important point that I want to talk about. How many of you have heard of your individual carbon footprint? Right? How many of you knew that's totally a scam by the fossil fuel companies? They came up with that idea to shift blame on the individual consumer for climate change, even though as individual consumers we have very little that we can do to solve climate change. They came up with the whole idea of an individual carbon footprint to shift the collective onto caring about you as an individual instead of them as a company. Right? Large corporations and governments are the main contributors. So that means the way to change is organizing government and large corporation regulation, not individual decisions like to recycle or fly one more time less. Right? Organizing and voting and politics are actually the ways to solve this problem, which makes me and many other scientists squeamish. But that's how it works. Can we undo emissions? Is a great question. Yes, kind of. Right? So fossil fuels are emissions that are millions of years old that shouldn't be in the carbon cycle. We know that some ecosystems take those in naturally, like wetlands, for example, especially coastal wetlands. So by restoring those wetlands and increasing their size, we can draw down some of those emissions, right? By planting forests that we've cut down, we can take out some of the CO2 that we've emitted. Long term, the ocean will absorb most of it, but that's thousands of years. We don't have time for that process. Some people are talking about technological fixes, like sucking CO2 out of the air and burying it underground. I hate that idea because it usually has a downside that we don't think of until it's too late. But we need all options on the table. So there are some ways, but the best way is to just stop emitting, which we're still doing really rapidly. Some organisms can adapt and will be okay. Lots can't, especially ones that have very specific requirements. Climate is changing too fast for them to adapt. Right? So if you have a really wide tolerance, think back to evolution. If you have a really short generation time, you can have faster evolution. You can adapt in time. Like microbes, little small bugs, roaches will be fine, I'm sure, right? But large things that have long generation times or very specific niches, it's just too quick, right? We're in an extinction event because it's too quick. We can't adapt that fast. Yeah, a lot of us will be underwater soon on the coast. Not the sun and global warming